Good morning, friends. Thank you for watching my previous sessions. In this session, we are going to focus on circuit breaker pattern. This is one of the beautiful pattern to prevent failures or fault tolerant in the landscape of microservices. Okay, before understanding what is circuit breaker, let's keep that aside. Let us understand what is cascading of failures. For example, if a B microservice is failed, then A is calling B, then A shouldn't cascade the failure of B to its upstream. For example, zero microservice 0 is calling 1 and which is calling 1 is calling 2. If there is failures in 2, then 1 shouldn't cascade that failures to 0. So it shouldn't cascade those failures to upstream. At the same time, it should be a fault tolerant to the failures of B. So in our previous session, we have seen the retry mechanism, right? So the retry mechanism helped us not to cascade the failures and make the service fault tolerant. That's good pattern, no doubt in it, but it won't work out always. For example, if you observe that B service is having failures, if you are repeatedly retrying it, right, there might be a situation that B can become worse. If it's not only the failure I mean by some errors, or if it is having a performance issue, if you are trying to do a retry, then the performance of B will further go down and you don't give enough breathing space for B to recover. So retry is a good pattern, but it doesn't work always. So we need something which is a lot cleaner way to handle those type of faults. Okay, so circuit breaker is one of the pattern which will help us to prevent cascading of failures either to the upstream or either to the downstream. So that is what a circuit breaker pattern is. So assume that circuit is like an electrical circuit, right? You know electrical circuit, right? So the electricity goes through that circuit. So if the circuit is in open state, electricity won't pass to it. If the circuit is in closed state, the electricity pass through it. So it is like a circuit to, it is like a gate which keeps how the electricity should go, right? The similar analogy you can apply when a microservice A is calling microservice B. Okay, so if you have a circuit in between, and if you observe that B is not behaving well, then you prevent calls going to B and give a breathing space for B to recover, and then you allow calls go to B. So that is what a circuit breaker is doing. So essentially, circuit breaker will help the B microservice to recover, and it gives some breathing space. And once it recovers, then it closes the circuit. Then automatically the calls goes from A to B. So only two terminologies here, quite confusing. Even I understand. You should follow the analogy of electricity. When a circuit is open, then the calls won't go to it. When circuit is closed, then calls from A to B goes. Okay, I'll reiterate. When a circuit is open, then a call from A is not going to go to B. When a circuit is closed, then call from A is going to go to B. Anyhow, I'm going to show you with a whiteboard to make it very clear. This circuit breaker pattern has half open state and those things. We are going to discuss how the circuit open and close behavior is changed, what are those rules. But this is a very beautiful pattern. If you want to implement on your own, it's not easy to do that. So you need to have some good library like Resilience4j. You people use historics, but here we focus on Resilience4j, where as usual, this comes with as an aspect. You just annotate your function. That's all. You are going to get this circuit breaker functionality. You need not to do anything. It just comes with an aspect. You just annotate with circuit breaker and a callback function or a fallback function. Then it's done. I'll explain you what is a fallback function and stuff. Essentially, you need to understand when circuit is closed, then calls from A to B goes. When circuit is open, then the call from A to B doesn't go. On what conditions the circuit become open and on what conditions the circuit become closed, we are going to define. So let us take, as usual, our previous example. We found that B microservice is very faulty microservice. So if you make a call to B, 50% of calls are going to fail. Okay, so earlier we overcome that issue by using retry, but that's not a right pattern, I'm saying, because you are troubling B further if it is having some issues. Instead of that, if B becomes to a good state, then if you try to call B, then it's a right pattern. So how do you know that B recovered? All those things we are going to learn. Okay, so as usual, yeah. So as we discussed, right, what is fault tolerant, what is circuit breaker, why do we need circuit breakers? Yes, we in a land of microservices, you expect failures to happen. Failures are bound to happen. You cannot escape in it. So then you need to have these patterns ready. So understanding the circuit breaker module, when I'm explaining your code in detail, I'm going to explain and few important configurations which you need to. As a standard practice, we have this entire demo. What I'm going to show you here is in the GitHub repository called Circuit Breaker Error Calls. So you just clone my Resilience4j Hello World project. In that, you go to this folder, then you have this entire code, and there is a nicely written compliance page where you can go through it and play with various configurations. And so the same concept, right? So the circuit breaker is facading the greeting API. In a normal call, A calls directly B. Instead of that, we are having a circuit breaker. We are having a circuit between it. Okay, when a circuit is closed, then the call from A to B goes. When a circuit is open, then the call from A and B doesn't go. Okay, so that's very simple way to understand. So let us start service B, or let the, as usual, the standard practice. What we do is when you cloned my repository, then you go to the folder, then standard is like maven clean install. So we are going to build the artifacts because the GitHub repository will not have the artifacts. I built then two services, service C and service B. Let me start service B, just a standard REST API, Spring Boot based REST API. I'm just starting it. So here I'm going to use JMeter to generate the load. Okay, so I'm using JMeter to make the calls to REST API. It's very easy to see those errors, visually represents better. Okay, curl or Apache benchmark, you can use them, but I generally feel that JMeter is a lot cooler tool to do a performance test or to generate load and those scenarios. Okay, so if you see, I'm one client, ramp up period 1 second, and essentially I'm calling service B directly, but no one directly calls service B because A is going to call B. That's what we discussed, right? So I think I have to go to whiteboard and explain you. Okay, as the things progress, I'll explain you. So one is I'm directly calling B and see what's the behavior of B. So if I run here, then view results in tree, then you see here my 6 requests are failed and 4 are successful. So my error rate is approximately the 60%. So 6 calls to B is failed. What is the reason? We really don't know. But those failures shouldn't affect A, and those shouldn't affect the predecessors of A, okay, or the client. Anyone shouldn't be affected. That's what our goal. And at the same time, we are not going to retry. We are going to use a circuit breaker pattern. Okay. So now let us come to the little bit of rules of circuit breaker, which will help you to understand. We understand the behavior of B, right? It's a faulty service and it generates 60 errors. So let us jump to the whiteboard. Sorry, I'm having a trouble here with my whiteboard. Something gone bad. Okay, I'm back. Okay. So now let's understand. Sorry for what has happened. Now there is a microservice and there is a B microservice. A is calling B This is a normal flow. Now instead of that, what we'll have is A calls, we have a circuit breaker in middle, CB, circuit breaker, okay, CBB stands for. So we have B. So the circuit breaker, if it is in open state, so like, let me do an eraser. If it, so if circuit breaker is in open state, I'm not very conversant with this tool. So when circuit breaker is in open state, this is open, right? When circuit breaker is in open state, the request won't go to B. Then what happens? When a circuit breaker is in open state, it is going to call fallback method. It is going to call fallback method. Okay. So you define a fallback method on A. So when circuit breaker is open, instead of calling B, I will just return the data from cache. So that is what I have a behavior. So A is going to return data from cache and it is going to serve the client. So it's not going to further disturb B. Now, important states we have. So we have open, okay, we have close, and we have another important state called half open. Okay, this is a little bit confusing. So what happens is from when a circuit breaker starts, it will be in the closed state so that the data flows fine. So you need to say when from closed to open state the circuit breaker should become. Okay, when it should come. So I say that if I get, I don't know here what I said, if I get 50% of failures. So if I say that A is calling B, if there is a 50% of failures in those calls, then open the circuit. So don't further call. So sorry. What I'm saying, okay, if A is calling B, if there is a 50% of failures, okay, then make the circuit open. The circuit goes to open state and the calls are not going to go to B. That is what the failure rate. So pay attention to these entire configurations. These are the one which you need to get hang on. Then rest is like very simple. You're not failure rate, but how failure rate is computed is important thing. How failure rate is computed is like, we are using sliding window 10. So I need to get 10 calls. I'm using sliding window. There are two types of sliding window. This time based, another one is count based. Here for simplicity's sake, I'm using count based so that I can easily reproduce and show it to you. Out of 10 calls, okay, if 50% of the calls are failed, then the circuit becomes open. Okay, so what do you mean by 50%? Out of 10, the 5 calls needs to be failure. That is like 50%, right? So that is what my failure threshold 50%. But there is a catch here. So the minimum number of calls for me to start computing 50%. Okay, so for example, if I get 5 calls, okay, till 5th call I don't compute any error rate. So once I got 5th call, I compute from 1 to 5. So if 1 to 5, if 2 calls are failure, 2.5 or 3 calls are failure, there is no half call as such. From 1 to 5, if 3 calls are failure, then it computes that 50% rate is met, okay, and it opens the circuit. So this is what you have to understand. So what are the minimum number of calls I need to consider to compute the error rate? So I say that 5, my window is 10. In my window, wait till 5 calls comes. In those 5 calls, if there is 50% of failures, then you open the circuit. That's very simple. Okay. So then there is a concept called half open. Okay. So when the circuit is open, then it directly don't go to closed state. Okay. So there is an intermediate state called half open. So there is, so you need to say, you need to give a hint, right? From open state to the closed state, when should I go? I'll say that 1 second. After 1 second, you try to close the circuit. Once again, after 1 second, it closes the circuit. And then the calls try to go, and once again it sees a failure rate, then it will open. So that is what a open, that is what from closed state to open state. Okay, so wait duration is like, once it is in open state, I don't want to ask it to open for n period, right? That's wrong. You need to retry, you need to close the circuit and see how B is behaving. The reason to close B is to understand the behavior of B. So you close the circuit, then A directly calls B, and if once again there is a 50% of failure, then once again you open. So there is an intermediate state called half open. Instead of completely closing the circuit, it will half open it, and I'll say the number of permitted calls in half open state is 3. So circuit breaker, you just half open the circuit and send 3 calls. In those 3 calls, if you get 50% of failure, then go to open state. Okay, so don't allow further calls to be. This is what I meant by number of permitted calls in half open state. So from let me explain you on the whiteboard. Okay, from open it goes to half open, then half open it goes to closed. Okay, so this is what is going to happen. So do remember, if there is an error comes in, if in open state there is an error, in half open there is an error, all goes to fallback methods. Okay, or I shouldn't say error. So if in open state it always calls the fallback method. Okay, in half open state, if some error comes, right, in half open state you are calling B, then it goes to fallback method. So how do you, the rules here is, in half open state you will, in open state you will say how much time I need to be in open state. So here I said 1 second. So after 1 second it goes to half open state, and I'll say, I said 3 calls you should consider to send it to B. So in half open state it will send 3 calls. If the 3 calls were, if 3 calls were successful, right, then it goes to closed state. If the 3 calls are successful, it goes to, if 2 calls are failed, like 50% failure has happened, then once again it goes back to open state. Okay, that is what you need to understand. In half open state, it will send the number of calls, and it once again it computes the failure rate. That number of calls, I said it as a 3 calls. So this is a state transition diagram: open, half open, and close. So open to half open will happen on when you said wait duration. I said wait duration is like 1 second. After 1 second, don't directly go into the closed state. From open to closed state, wait, go to half open, try, and once again based upon that computation come back whether to open or to close. Looks like little bit confusing, but very simple to understand configurations. So you understand what you need to understand. There are 3 states: open, half open, and closed. Okay, open state, the calls doesn't go at all. Closed state, the calls directly go. Half open state, you compute the number of thresholds, okay, number of calls that should go. So in any of the case, whether it is an open state, half open state, or closed state, if an error comes, you can always instruct to call fallback method, what needs to be done. Okay, so now to do that, so essentially we are not touching anything about service B. We are more interested in service A. So let us see. Service B is a simple application. Like did I demo the service A? Okay, so let us start service A. We know that service B is very problematic service. Let us try to implement circuit pattern on service A. Let me run, I'll disable, let me enable and generate request. The same thing, like I'm one user is making 10 calls. So user is making 10 calls. Okay, so let us see how the service A becomes, when half open to open happens and when to close. By default it will, the first state is like a closed state, like that A directly calls B. So let me clear all. So service A is running service B. Okay, now let me generate the calls. Okay, so the view result, all the calls are successful. That is what we need to give back to the customer, right? So for customer, he don't know whether we use circuit pattern, B service is what's the state. He doesn't care about. Okay, we are the one who get. So let us see how B behaved and how our circuit back pattern worked. So what happens is first four calls are failure. Okay, once the first four calls are failure, and when the fifth call comes, then the circuit breaker understand. Okay, the failure rate is like 100% or 90%. Let me open the state. Let me open the circuit. It open the circuit, and no further calls goes to service B. So service B won't get. Sorry, I should have cleared the previous one. The circuit B won't get the call. The service B won't get the call because the service A opened the circuit, and the fallback method is called. So if I show you, you need to pay attention to this simple logic, then you will easily understand the fallback. This fallback is slightly confusing, but pay attention to this. Very simply, you annotate with circuit breaker. This is my circuit breaker. So when an error comes, call fallback. There are two states in fallback, right? Or there are two type of exceptions in your fallback. Okay, one is when the circuit breaker is open state, I need to return it from the cache. Here I said I'll return it from the cache. When a subsystem is generated, first call itself is a failure call. You really don't know, right? If A calls B, then the first call itself is a failure call. Then you need to know what exception, right? I said this is the exception that I need to handle. So this is what the exception occurred calling B. So, and this is occurs only when circuit breaker is in an open state. So these are the two fallback mechanisms. Okay, based on their exceptions, you can differentiate the exception and how do you handle it. Or let me reiterate, this method is invoked when circuit is in open state. This method is invoked when the service and the actual call failed. That's it. Okay, when the circuit is in open state, this method is called. When the service itself failed, when you're calling the service itself is failed, and this method is going to call. Do remember one more important thing: when circuit is in open, this we are not going to call this at all. Okay, we are not going to call B. So whatever the greeting method is not going to be called when circuit is in open state. It will call the fallback method. So this is what you need to understand. When circuit is in open state, we are not calling B means we are not calling means we are not calling that some function which is calling B. That is nothing but greeting function. So if you understand these subtle differences, right, the small differences, then it's very easy for you to understand circuit breaker. Circuit breaker has three states: open, half open, closed. When it is in open state, the fallback methods are going to get called. The fallback method that is going to get called is like call not permitted fallback method. Sorry, the fallback method which is handling the call not permitted exception. If an error is thrown by subservice, then you have HTTP server exception. When it is in open state, this is the method is not going to get called. That's it. You got it. Very simple. I shouldn't reiterate so that it will be boring to you, but if you play with it, you will easily understand. The same thing, sliding window. I said window based 10. Okay, I'll wait till 5 call comes and compute. Once the 10 calls are computed, I once again make everything 0, and once again I start new window starts computing. So this is like count based I used. Then permitted number of calls in half certain state. I said 3 calls you need to monitor. In the 3 calls, if you get 50% failure, then once again go to the open state. If it is if the 3 calls are successful or more than the error ratio is less than 50, like instead of 50% there is only 20% failures, then go into the closed state. So that's what my failure rate threshold, and this is default. And as usual, this is the important thing. How do you see that B is problematic? You will monitor these exceptions. So you don't If B is having some communication error, you don't consider that is a circuit breaker error, okay? Or that is a circuit breaker, that's the error that circuit breaker needs to monitor. So these were the exceptions that you need to monitor. So circuit breaker is fairly fairly complex pattern if you want to implement on your own. But if you are using a library like Resilience4j, it's very easy to get onto it. Okay, so now I showed you the code, then I showed you the greeting controller. Very simple. You have two fallback methods and one call service B, and you can get that functionality with circuit breaker. Then as usual, the pom.xml has three dependencies. One is like your AOP, actuator, and Spring Boot. These are the three dependencies which you need to have to get this functionality. Then service B is not a great service. It's a simple Spring Boot API, which generates randomly 50% of calls or failures. So I just had the randomly generate an exception to demonstrate this. So this error, the error to make the service be and bad service, I just induce that error behavior. So hopefully you understood the circuit breaker. If you have any questions, drop me a note. Thank you for watching.